warahmatullahi wabarakatuh. Welcome to Lab 2. We name Wesam Adil Asatli, ID 1085899. Today we'll talk about the flow control and using Wireshark to analyze network traffic for Lab 2. So we first started with the part 1, data link flow control. We have polynomial division, divided following the instructions of A and B. First, the sixth digit of the first student, C and D, and third, the sixth digit of the second student, and so forth. We follow these instructions to do the polynomial division. And by watching the video link down below, we have found the data word and the divisor, as well as the code word and binary. As for task 2, the trivial file transfer protocol, we have to follow the instructions from 1 to 4, 5 blocks. If student ID is even, then second is lost. And if it's odd, then third is lost. And you have to draw the flow control in the chart provided below, and describing sender and receiver how they will behave. Stop and wait RQ here, client server. We can show the from the first to and the receiver, and we got even the ACK and the frame. As you can see, next we have the Wireshark. We have to install the Wireshark, which is a protocol analyzer with four instructions of one PC or more additional PCs. So following these instructions from 1 to 10, we set it up, we installed it, and we used the link for our guidance. After that, for part 2, we have to capture and analyze the local ICMP data in the Wireshark by using the instructions of the tutorials. And these instructions for the IDs, following these, we can attach our screenshot to show a command prompt for the name Ryan with the all information, IP configuration, a data network, etc., from the instructions, and with the subnet mask and the default gateway. After that, we have to take the IP address of the PC and that of the second device, which is maybe another PC or mobile device, to the LAN. I have done so with the screenshot, wireless LAN, wireless data, Wi-Fi, all the information there, configuration. Then we have to start the Wireshark and begin capturing the data by focusing on the second device, the ping, the IP addresses, and then we attach the screenshot. You can see the reply there with the byte and time, the ping, and then we use the command trace art of the second device to show the screenshot, which we have done, and the tracing route of the information of the Wi-Fi, the capturing, the protocol length info, and as well as the destination of where the source is, Internet Control Message Protocol. Then we can see the data is appearing in the top window of the Wireshark as shown. Information about the second PC. Then we have start part 3, examining the header fields in an Internet 2 frame by reviewing the Ethernet 2 header field description of the lengths, destination address, source address, frame data type, and FCS. Now we just have to again follow the instructions. So following the instructions that are provided for us for the prompt and the adapter internet, we can get our connection details, connection DNS, physical address, DHCP, the normal Wi-Fi connection settings of where we are located. That's a screenshot, and then we have to examine the internet frames in a Wireshark capture by attaching a screenshot that shows that the packet generated by ping is issued from the PC host to its default gateway, and it will highlight the frame details for an IRP display. So following that, we can see here the destination is shown, the address for the Ethernet. Then we have to examine the Ethernet header from an ARP request. These are the informations that we have for the source address, destination address, email that we talked about. And these are the questions. What is significant of the content in destination address field? That it's sent to all the hosts on the local network. That's all left. Why does the PC not broadcast RP sending first ping request? Because the PC does not know the MAC address of the destination IP, but it sends it to the broadcast ARP to know which device has the destination IP. That's the unique MAC address that you have in the first frame. And what is the vendor ID unique of the source NIC in the ARP reply, which is the Netgear as vendor ID portion of the MAC address, the OUI, which is the 3 octets, 3 40 469A. The NIC serial number would be 99C572. Next, part four, use Wireshark to capture and analyze the Ethernet frames by determining the IP address of the default gateway on the PC, which is 10.77.01, which is the device that we're using. Then step two, we've captured the traffic on the PC using Wireshark, and then step three, filtering the Wireshark to display only the traffic of the ICMP. And all these steps following the command prompt, not capturing the traffic, and examine the first echo. We can see here our MAC address of the PCIC is this unique number, I digit, and the default digit with the MAC address would be this unique, and the type of frame, which is IPv4, of course. The source IP address would be unique 10.77.168, and the destination IP address 0.701. The last two highlighted octet spell would be high, and the device and MAC address displayed would be as destination address, which is this digit. Then we have to capture the packets for the remote host on the instruction the command prompt pointer and ping Cisco. We can see that first ping request frame what the source and destination MAC address is this digit, this for the source and this for the destination. And what is the source and destination IP address to contain data field of frame? For the source is 10.77.168 and destination is 23.208.231.13.18. We compare these addresses to the one step 6 and see that destination change only destination IP address, why it has changed, and while MAC address remains the same, but see because the IP address changed because the packet is going to a remote gateway instead of a local gateway, or the MAC address remains the same because the frame sent the default gateway MAC address. Then we have to insert a Wireshark screenshot of the ICMP traffic through a firewall for the ICMP traffic through the firewall through Windows. This is what we got. The frame and the internet and the address and destination, destination, the protocol and the header. Then we have to examine the captured data. And following the instructions of the plus sign to the left of the internet, you can see that the source MAC address of the PC interface is this unique digit. And the destination MAC address matched our team member in the MAC address STC4628C35960. How is the MAC address of the ping PC obtained by your PC? By sending out ARP podcast by the second PC MAC address, and the second PC replies with the MAC address. Then part 5, we have to capture and analyze the remote ICMP data in Wireshark by following step 1 to capturing data on the interface, and then examine and analyze the data on the remote host. You can see that the remote IP address for Yahoo would be that unique digit, and then the MAC address for that IP address, MAC address. What is significant about this information that both Cisco and Yahoo have different IP addresses, but the same MAC address. And that shows that the MAC does not belong to the remote websites, but only the remote local router or gateway. Now, how does this information differ from the local ping information seen in part 1? That the local ping information is the actual MAC address of the destination device, but for the remote website that we have seen the MAC address of the router. Next, then, why does the Wireshark show the actual MAC address of the local host, but not actual MAC address of the remote host? That's because only the MAC address shows the local network, but the Wireshark shows the MAC address of the router for the traffic for the remote host. Thank you.